Welcome back. This is the second video in the ionic bonding video series, and in this video I'm going to tell you all about how you can tell if your compound is an ionic compound or not, just by looking at the ionic formula. Okay, let's get started. In this part of the board here, I've got how to determine if your compound is an ionic compound or not. It says if the formula contains a nonmetal, which is found on this side of the periodic table, hydrogen counts as well, and it's also combined with a metal, which is usually found everywhere else, usually over here, and then it will be an ionic compound. This is because nonmetals will steal electrons. If they steal extra electrons, then they're going to have more electrons than protons afterwards, won't they? So if there's more negatives, then it will have a negative charge overall. And the metals, they tend to lose their electrons because there's very few on the outside shell. Therefore, they will have less electrons afterwards than their protons. So that will mean there's more positive charge overall. So once these things combine together, they will stick together and form these ionic bonds, this electrostatic attraction between a positive charge and a negative charge. Right, let's move on. Here's some examples here, and to save yourselves a bit of time, I've color-coded them. The metals I have written in blue, and the non-metals I have written in orange. So let's have a look at these. Some of them are familiar to you. H2O, which is the water that we drink, it's only composed of non-metals, so it does not qualify to be an ionic compound. Let's look at this one, CO2. This is the gas that we breathe out. And it's also the gas that plants take in sometimes. It's only made of nonmetals. It doesn't satisfy the condition, so it's not an ionic compound either. Let's look at lithium fluoride. Well, it's got a metal and a nonmetal. That is an ionic compound. H2SO4. This is one of my favorites. It's called hydrofluoric acid. No, sulfuric acid. Sorry, I had a lapse in memory just now. Sulfuric acid. This is definitely not an ionic compound because all of those elements that it's made out of are all nonmetals. Let's look at the others. Well, in this case, I've got metal and nonmetal, metal, nonmetal, metal, nonmetal, metal, and nonmetal. So in this case, the rest of them are ionic. Ionic is a short name to say ionic compound. So when I say ionic, I actually mean that I'm trying to say ionic compound. However, sometimes I'm a little bit lazy. Now, let's look at how we can name these compounds. Well, remember from our previous video that the metal, once it becomes an ion, its name doesn't change at all. So if its name is lithium beforehand, its name is still lithium. So I'll write it down. Lithium. Now, the other nonmetal, however, when it forms an anion, its name will change once it gains that extra electron. So, if its name is normally fluorine, it'll change to fluoride because the last part of the name changes. So it's lithium fluoride. Whoops, F-L-U-O-I-D-E. It's one of those weird ones. It's like the flu plus an O, and then you add the rest. Let's look at this one, iron oxide. It's an oxygen atom, but again, the last few letters of oxygen, change them and put IDE on the end instead. So this is iron oxide. Let's look at this one. We've got magnesium. Its name doesn't change when it becomes an ion. So we got magnesium. Now we've got the same oxygen again, so oxygen becomes oxide, and then that's the name. Let's look at this one, copper. Its name doesn't change because it's a metal, so copper. And this one here, this one is a tricky one. This is a group of nonmetals. We give that a name. If there's more than one atom, we could say it's poly, meaning more than one, like a polygon, multiple sides. Polyatomic for atoms, polyatomic ion. So we treat this as one group. Now these tend to be quite tricky. You might find them in grade 10 and grade 11. However, you have to look them up in the table to recognize them. So in this case, its group name, its polyatomic ion name is sulfate. You look it up in a table. Okay, this one here, strontium. Strontium is a metal, it stays the same. So as we go, strontium. And we got chlorine. Oh, chlorine. Chlorine. It's a non-metal. We've got to change the ending of its name to chloride. Now, I hope this is still in the frame of the video. If not, I'm very sorry. But that's it. This is how you tell if it is an ionic compound or not. Here's a few examples, and this is the process we use to give them their names. All right, in the next video, I think I might go through some of the properties that you might find in the ionic compounds, but that might be for another day. So no more videos for now. See you later. Bye.